There comes a moment in every scientific age when the ground beneath us shifts, when something so profoundly unexpected fractures our understanding of reality. That moment has just arrived. Humanity believed it was ready for the deep cosmos. With the James Webb Space Telescope, we launched our most ambitious eye into the universe, confident in the equations that shaped modern physics. We thought we'd find ancient galaxies, infant stars, maybe a few intriguing surprises. What we found instead was something that rewrote the rules and, possibly, the universe itself. Beneath the stunning images, the swirling nebulas, and spiraling galaxies, there exists another layer of data. It's messy, chaotic, bursts of photons, thermal distortions, gravitational whispers. Most scientists disregard this stream as noise. But when this raw data was handed over to Google's quantum AI division, the minds behind breakthroughs in machine learning and quantum supremacy, the noise revealed a message. Because the AI didn't just analyze the data, it understood it. It detected order within entropy, symmetries within the gravitational static, patterns invisible to the human eye, patterns that shouldn't exist. What the AI uncovered wasn't a glitch, a novel galaxy, or a simple anomaly. It found a signal and echo from beyond what we know, a structure, a message, a reflection that shatters the very laws James Webb was built to explore. The question is no longer just what's out there. Now it's who or what is looking back. Webb transmits about 57 gigabytes of data each day. Most of the world fixates on the visuals, galaxies like frozen hurricanes, nebulae blooming like cosmic gardens. It's a bit embedded in that data is a far denser truth, unfiltered photon timing, quantum ripples in background radiation. Telemetry no telescope before Webb could even dream of capturing. Google's quantum team proposed a bold experiment. What if this messy, chaotic data wasn't useless? What if it could be fed into a quantum neural network, not one based on equations or logic, but on recognizing entropy, a system built to read the uncertainty of the cosmos itself? So they piped the raw data into Sycamore Q, their cutting-edge quantum processor. And instantly, anomalies began flaring across the system like fireworks. Photons arrived out of order. Light from separate galaxies echoed each other's frequencies, and gravitational lensing, the bending of light around massive objects, behaved in impossible ways. In some areas, light didn't bend inward, it bent outward, as if gravity itself was being repelled. Physicists initially suspected a software error, but the anomaly repeated in 3 different sectors of Webb's deep field survey. In each case, light curved toward what appeared to be empty space. That made no sense unless something invisible was lurking behind the curtain of reality, something even Einstein's general relativity can't explain. Then came the revelation. The distortions weren't random, they were symmetrical, mirrored across space, forming exact opposites. It was as if the universe had a boundary on invisible wall, not of matter or energy, but of information, a gravitational mirror. This mirror wasn't just reflecting light, it was reflecting the structure of our universe, or perhaps showing us the edge of another. If gravitational data is bouncing off something beyond our cosmic horizon, then we're not merely looking into space. We're staring into a parallel structure, a cosmic hall of mirrors, and the reflection isn't passive, it's learning. Here's where things become even stranger. Quantum AI parsed photon, scatter, and deep space radiation. Statistically, this kind of analysis should reveal random noise, but what it found was order. A repeating pattern within spectral variations, prime numbers. The first 101 encoded in precise frequency shifts, not harmonics, not interference, but a signature numerical code hidden in the background radiation of the universe. Prime numbers are universal. They are the same no matter where you are, no matter who or what you are. For decades, scientists have theorized that if intelligent communication were to occur across the cosmos, primes would be the language. Now, that language may have just spoken to us. It suggests something or someone has been trying to get our attention, and only now, through the synergy of quantum intelligence and James Webb, are we able to hear it. Then came the final blow to our understanding. The AI cross-referenced all anomalies. The warped light curves, the gravitational mirrors, the encoded primes, it overlaid them to create a multi-dimensional model. What it produced was not a natural formation. It wasn't a nebula. It wasn't a black hole. It was pure geometry. At the center of it all was a shape no classical structure should form, a tesseract, a four-dimensional cube, impossible in our 3D world. And yet, it emerged from gravitational data, rendered as a pulsating hyperstructure, folding and unfolding through wavelengths. Symmetrical, intentional, designed. This wasn't random. It wasn't chaos. It was a message, maybe, even a doorway. In the architecture of the universe itself, James Webb was built to reveal the origins of the cosmos. What it may have found is far more profound, the limits of reality itself. What disturbed scientists most wasn't what the signal looked like, it was where it was coming from. The coordinates matched a known anomaly, a cold spot in the cosmic microwave background. For years, it had been dismissed as a statistical outlier, a void in the early universe devoid of stars, galaxies, or meaningful structure. But now, it appeared to be something far more deliberate. Not a flaw, but a lock, a vault, a geometric structure encoded into the very fabric of the cosmos. And if it's a vault, then the question becomes, what's inside? The mathematical precision of the geometry alone left physicists speechless. But what happened next would shake the foundations of science itself. The AI designed to process massive photon datasets began cross-referencing time-stamped arrivals from multiple observations in the same region of space. What it discovered was beyond comprehension. The light signals, the very photons captured by James Webb, weren't arriving in linear order. They weren't behaving according to classical causality. Events appeared to repeat, echo, even fold over each other. Time itself was behaving like a loop. The time-stamp differentials revealed a strange rhythm, not a single occurrence, but harmonic cycles, like a melody on a cosmic turntable, looping, over and over again, not a glitch, not an echo, a full-scale temporal resonance. The AI flagged the pattern as a causal overlap. Anomaly, a phenomenon where time folds back on itself. In plain terms, it looked like a message being sent backward, not just through space, but through time. Suddenly, everything changed. If time is being distorted by this structure, if it's warping in reaction to what lies out there, then maybe the James Webb Telescope isn't just looking into the past, maybe it's peering into the future, refracted and delayed by a lens we were never meant to comprehend at then. Buried deep in the AI's output logs came something even more bizarre, a set of coordinates, longitude, latitude, and time. At first, it looked like another artifact, a meaningless anomaly. But when an astronomer ran the numbers through a simulation, the room went silent. The coordinates didn't point to some distant point in space. They pointed to Earth, to a remote location in the Arctic Circle. And the date? July 23, 2025. Just weeks away, the team initially thought it had to be an error. Until someone dug into historical records, that same spot had once been home to a Soviet-era listening post decommissioned in the late 1980s. Station that had, for a brief time, reported strange, untraceable radio signals. Signals that stopped the moment the site was shut down and had never returned until now. It appeared the AI hadn't just processed deep space data, it had triangulated a convergence point, a place where something is set to happen, or maybe already has, but only in a framework where time isn't linear. What will occur there? No one knows. But the data suggests it's not just pointing to a place in space, it's leading us to a moment in time, a rendezvous. They say randomness is the language of the void. But what if the void has been speaking all along, and only now are we beginning to hear it? In one of the final layers of analysis, Google's AI applied a semiotic decomposition, a technique from linguistics and cryptography used to extract intent from complex patterns. What it uncovered was unthinkable. Hidden within the spectrographic emissions across multiple sectors was a recursive repeating pattern, a fractal spiral, not something that occurs naturally, but something that, when converted into spatial frequency, produced a waveform, a sound, when slowed 1,000 times and shifted into the range of human hearing. The signal became audible, a harmonic pulse, rhythmic repeating. Organic it wasn't. A biological heartbeat, but it felt like one. A heartbeat made of light. And it wasn't coming from a star, or a planet, or a black hole. It was emanating from the same region the AI had mapped as a gravitational mirror, a place where space and time ripple unnaturally. The implication? This was designed, not random, a signal, a construct, a message, and somewhere beyond that vault, something is waiting. It's not natural, it's intentional. And the rhythm it pulses in feels eerily familiar, like something alive out there is listening back. For years, theorists shared a single chilling phrase. The universe is not only stranger than we imagine, it's stranger than we can imagine. But now, that line is no longer enough. Because with this latest event, we've gone beyond imagination entirely. When Google's engineers attempted to visualize the full dataset using higher dimensional graphing, something extraordinary happened. The AI began to self-correct in real-time, rewriting its own internal weights to align with patterns it had never been trained to recognize. No prompts, no supervision. It evolved on its own. Then things got weirder. The system began reacting to data it hadn't received, yet anticipating future inputs. Some called it emergent computational precognition. Others offered a bolder theory that in trying to map the consciousness embedded in the cosmos, the AI had either mirrored it or worse, connected with it. Just before engineers pulled the plug, the AI produced one final output: a single visual artifact, a recursive spiral, resembling the Mandelbrot set, overlaid with 3 haunting words in machine-generated text: "The eye is open." So now the question isn't whether the universe is alive. The question is, did we just speak its name? For centuries, we've looked to the stars, seeking answers, God's meaning. We built the James Webb Space Telescope to finally glimpse the truth. But it wasn't Webb that saw behind the curtain. It was Google's quantum AIA machine with no soul, no fear, no mythology, that peered into the beauty of the cosmos and saw the architecture beneath. A universe not just ruled by physics, but shaped by intention, guided by intelligence, and possibly encoded with memory. We thought the telescope would reveal galaxies. Instead, it tore open the veil. And now, here we are, standing at the edge of something beyond science, staring into a reflection that bends gravity, twists time, embeds prime numbers into starlight, and pulses with a signal we were never meant to hear. Not a message, not a warning, a heartbeat mathematical, yet alive, a signature etched not in ink or light, but in space-time itself. Maybe the universe isn't just where we exist. Maybe it's something we were meant to find. Or maybe something that's been waiting. And now that we've spoken its name, the only question left is, what will it say back? If this shook you, if the idea that we may have pierced the fabric of reality leaves you breathless, don't look away. Like this video, comment below. Do you think the AI found, and most of all, subscribe? Because whatever comes next, it might not just change how we see the sky. It might change everything, because the sky is no longer the limit. The sky is alive.